Now we have to understand the behavior of the dipole in uniform external electric field as well as in non-uniform external electric field. So what happens when the dipole is placed in uniform electric field? Okay, now see here, suppose as shown in the figure, we have uniform electric field that is in the direction as shown in the figure. Uniform electric field means the intensity of electric field at each and every point, that is same one, and at each and every point the electric field that is in the same direction. So when we represent the uniform electric field, at that time we represent it with equispaced parallel arrows. So at present the electric field that is in the direction as shown in the figure, and that is the uniform electric field. Now suppose the dipole is placed in the uniform electric field at angle theta with respect to field. Angle theta that is considered between dipole moment and electric field. Okay. Now we already studied this thing. When any charge is in the electric field, the force acts on it, that is Q into E. So here on the positive charge, the force that will be in the direction of the field, and on negative charge it is in the opposite direction. So see here, the force on plus Q charge, that is in the direction of the field, and that is QE. Then force on the negative charge, means on minus Q, that is in the opposite direction of the electric field, that is minus QE. But now see here, two forces are acting. These two forces are equal in magnitude and opposite in direction. So net force will be zero, but these two forces are not collinear. It implies that it will form a couple. And now it will produce the torque. Clear? So here, due to net force that is zero, there will not be the translational motion of the dipole. But due to torque, we'll get the rotational motion. So now, here, the torque, that is how much? See here, the distance between these two charges, that is represented as 2a. Now this angle is theta, so this one is also theta. So perpendicular distance between these two forces, that is given by 2a sine theta. Now as per definition of the torque, we can write magnitude of any one force into perpendicular distance between two forces, that is the torque. So magnitude of the force, that is QE, and the perpendicular distance between these two forces, that is 2a sine theta as shown in the figure. So QE into 2a sine theta. So tau, that is Q into 2a. So torque tau, that is force QE into 2a sine theta. So we can write that is tau equal to Q into 2a into E sine theta. So tau, that is P E sine theta. So in vector form we can write torque tau, that is P cross E. Okay. Now under the effect of this particular torque, the dipole will be rotated in such a way that theta will be decreasing 1. And when it is aligned with the field, then theta will be 0, so torque will be 0. Clear? So whenever the electric dipole is placed in the external uniform electric field, the torque acts on it, and under the effect of it, it will try to align itself in the direction of the field. Now, if the electric field is non-uniform one, then the force on positive and negative charge will be no doubt opposite in direction, but not equal in magnitude, because field is non-uniform. Means at a different position, the field intensity is different one. So at the position of positive and negative charge, the field intensity, that is different one. So forces are different in magnitude, but opposite in direction. So here some net force will be there, as well as some net torque will be there. And under the effect of this net force and torque, okay, it will execute the translational as well as rotational motion. And rotational motion will be executed till it is aligned with the field. And once it is aligned with the field, then after the translational motion will continue. Clear? So this one is the behavior of dipole in external field.